recording. Okay. So where am I here? Okay. So we kind of left off yesterday getting into building that pet adoption API and kind of working through that. We had a little bit of stumbling blocks as far as just getting everything working, so we didn't get all the way through there. So we have to kind of finish that up, and namely we needed to do two things. We needed to implement a route to update pets and a route to delete pets. And I kind of asked you to try and play around with that yourself at home. I also kind of, after you left, kind of built my own version, so I'll kind of show you how I do that. One of the things to kind of understand in here is we're starting to build up applications kind of at this scale. And a lot of times there's actually not a single right answer. There's more than one way to do a lot of these things. And so that's what I was kind of telling Evan at the beginning of this. There's more than one way that we can do this. There's more than one way to architect this. If you look up examples of how to build a REST API with Node, you're going to get 5 different answers. I was kind of looking at different tutorials and whatnot just yesterday, and like they're doing it every different way. There's so many different ways you can set this up, right? So what I'm giving you is kind of the way I do it, the way I set it up, that kind of feels like it scales the best or kind of works with the kind of constraints that we see in industry. So what I'm trying to do is give you kind of my take, my pattern to it. And so I do expect you to kind of follow that pattern, but just recognize that there are multiple ways to do it. And just because you maybe end up with another approach, maybe that doesn't mean it's wrong, but there are some cases where maybe one approach is better than another. Okay? So that's what we want to kind of finish up here. And then I'm going to set you guys loose on Lab 401. I do need to make one mention, and don't let me forget this. When you set up 401 and use the issue tracker project, you'll want to use your Atlas cluster for that. The examples I've done so far have been using your local database, but when you do the issue tracker, you definitely want to use the Atlas cluster that you've already set up. That's not hard. It's just a matter of putting the URL in, basically. So I just want to show you how I want you to do that. So don't let me forget to kind of cover that before I set you loose. Okay? Also on this list of topics, we had Joy we need to cover at some point for validation. I cited for moving that. I was kind of looking at the schedule and figuring out where to fit that in and all those kind of things. So I cited for moving that to Monday next week. So Monday we'll cover Joy. And so that is in the reading assignment. You saw the announcement on Discord, the reading assignment's up there. So that includes everything we've already talked about today, as well as the content about Joy, which we'll cover next week. So plan there is we'll do that. There's a Lab 402, which will be strictly around Joy, Monday and Tuesday. Wednesday next week, we'll be doing 403, which will be around child elements, and namely getting into things that are kind of nested inside of other things. So for instance, looking at the comments and the test cases, which are kind of part of the bug. So that's your 403. And then 404, we'll be looking back at aggregate pipelines and search interfaces and how all that fits together. Does that make sense? So I've been working on trying to get ahead on a few of the labs lab assignments this morning, so I expect to have all the way up through 404 up on Insight Ranken tomorrow. So you'll see a few more things, and part of that's just because I know that people are going to move at a different pace through these labs. So if you get done with one of these 401, 402, 403 labs, 404 labs early, great, move on to the next one. Because some of them will take you shorter or longer than what's allotted. Okay? Trying to build in some padding as much as I can, though. Okay, so let's take a look at the pet adoption project. So I'm going to pull this back over. So where I would start is thinking about what we want to do with the database side of things. Okay, so I'm going to start here. So one of the things I might change, this is kind of something I went back to, with the pet, I was kind of looking at this, and it related to how I did update, and it kind of influenced, I went back, it's like, well, I should have done that on the insert as well. So when I take a pet and insert it, I kind of want to take some data from the user, but I also want to have the current date, right? I actually kind of want to add that. I think previously yesterday I had the responsibility of setting created date over in the route, right? I think, well, the next second thought, that makes more sense for that to be the database's job. Does that kind of make sense? Oftentimes tracking current date and current times. Sometimes you want the database to be in charge of it. So I moved that over here. So there's something interesting kind of going on. I'm still taking a pet as an object, but notice inside of insert one, I changed this to be something a little bit different. So I'm saying let's pass to insert one this thing, pet, and then created date is new date, okay? So this created date, new date is kind of the easy part, right? So basically you can tell from the curly braces I'm creating an object, right? I'm creating an object and I'm adding a created date field, and setting that to new date. Good? So what is this dot? So that dot, what we call that here is the spread operator. That is a relatively new operator in JavaScript called the spread operator. It's not to be confused with the rest operator. So for instance, if I have args dot, this is the rest operator. And dot args, maybe call this R or array. Now I'll just call it args. This would be the spread operator. And you can use it with arrays or you can use it with objects. It works a little bit different depending on whether it's an object or whether it's not. Okay? The thing to know is these are opposites. So the rest operator appears after the thing. The spread operator is before the thing. They're opposites. Okay? Everybody tracking with me so far? It's a really useful operator in JavaScript. Both of these. But here we just want the second one, which is the spread operator. Okay? So let's kind of explain what it represents and what it does. So if I take an object here, const pet is equal to the ID, is equal to species. Actually, I probably should be doing this on the, should not be doing this up here. I should be doing this up. Let me pull up Notepad instead. Come to think of it. Okay, so zoom this up. So what I was saying on the board, because I'm just realizing you can't see that online. So that was the args. And I need to switch this over to JavaScript. So this is the rest operator. Sprite operator. Okay. So if I maybe declare a variable, so maybe I have const pet is equal to species dog and name is final. Okay. So far, so good, right? So I've got an object. All right, so what I can do is I can do something like this. So I say pet2 is equal to pet, right? So this right here, right? This right here is basically a shorthand for this. So pet2 is equal to species pet dot species and pull in the name is pet dot name. So these two lines are basically equivalent. Okay. What the sprite operator does, it kind of takes the object and spreads it out, right? So you take from an object down to keys. So basically this allows me to copy all the keys and values from the pet from the pet that's here into this new object, into pet2. Basically pet2 is now a copy of the original. Does that make sense? We would refer to it as a shallow copy. It's not a deep copy, it's a shallow copy. It only copies one layer deep. Okay, does that make sense? The reason that I need that is because, well, what would happen if I wanted to, this is kind of long running, right? And especially if I have a bunch of properties that I don't necessarily know all of the properties ahead of time, right? This I could hard code, but I'd have to change that every time I decide to add or remove properties. Make sense? This code I would have to change constantly, and there's a lot of code duplication. Everybody tracking with me? So that means, hey, if I decide to go, add an age here, this code still works, and this code's broken now because I have to remember to copy the age over. So that's kind of the benefit of it. Not only does it shortcut your code, and not only does it make it more brief, more abbreviated, it makes it so it's easier to change, right? It's easier to adapt the program. Now, one thing you might ask, what happens if I do this? Because this is not the same. Just so we're clear, this is not the same thing. So if I say here pet : pet, this is not the same thing as pet2. What have I created here? Yeah, so here this is now a nested object. If I've got this, what I end up with is something that looks more like this. That's what it's going to end up with. Let me pull the age off of there because it's taking up too much space. So I've got a pet nested inside of this other object. So I don't want that nested, right? If I didn't have that, if I didn't have this operator, I would basically be, this is the option that I can do. I can't set all these properties. I can set it this way, long run, or I can set it this way, pass it as a nested thing, but I don't want it to be nested. Make sense? Because it turns out I need all of these properties at that same level. Good? Okay. Another way to think about this, another way you can think about this is I could do this, implement this using a loop. Is another way to think about the REST operator. Is I could loop through all of the keys and set all the values. So if I did something like const pet2, we start it with an empty object, and then I go for const key in pet, if you were going to write the loop out, this is basically how that would look. Equivalent to what the rest operator is doing. So internally, actually, the Sprite operator is kind of doing this loop. Does that make sense? It's actually implementing a loop. Is another way to think of it. You can think about it as shorthand for this. You can also think about this is also a loop. And in some cases I have found myself needing to write a loop and do this instead of using the Sprite operator. Okay? So everybody on board. You understand what's happening with this operator now. So what that means in my code is that this pet that I'm inserting is take all the fields from the pet, copy those over, and then also add the created date. So I'm creating a brand new object with all of these attributes plus that attribute. It's not the same. I'm not inserting the same pet object. I'm inserting a new pet object. Cool? That's one kind of gotcha there with the copy. So given that, this is how I'm going to build the update function. I'm going to call it update1pet. I'm going to take two parameters. I'm going to take a pet ID, and I'm going to take an update document. Okay, so the pet ID says which pet do I want to update, and update includes all of the fields that I want to change. Does that make sense? So I'm taking two parameters. And that means I can use that update object to determine which fields I want to update or don't update. If I set species, then it's update species. If I set name, it updates name. If I set age, it updates age. If I don't set any of those things, none of those things get updated. Make sense? So I can pick and choose with this any things I want to update. So I'm going to take that. We're going to say do a collection pets update 1. The first argument in here is which pet you want to update. So we're saying ID equals pet ID. And then this is where I say how I want to update it. So I'm using the set operator. The set operator says just replace the value that's there with this new value. I'm spreading out the update document. So again, if I update species, it will update species. If I don't have species in there, it won't update it. And then I'm also, regardless of all of that, always setting last updated to the current date. Cool? You know, if I didn't have this logic here, I wouldn't actually have needed the update, the Sprite operator. So just, I'm going to show you real quick. I'll undo this in a minute. Because the other way I could have done this is I could have just said update. And that presumes that I set last updated back in the route instead. Does that make sense? That's a perfectly valid solution too. It just means that you have to set last updated in the route instead of the database side. Does that make sense? So one of the things you were asking, what was for everybody's benefit, Evan, what was the question you were asking before this? What was the thing you said?
Yeah. So the first 10% of the work that's done is you have to read the data from the bottom.
Right.
And that can only be done inside the pet.js.
Right.
And the last 10% gets done is the actual database function itself, the one that's a DB collection, so on and so forth.
Right.
That can only be done in the other part.
Right.
Database.js, but the 80% is manipulating the data so they can be parsed for performing math on it.
Yeah. So when we're dealing with this, we've got two separate modules. We've got two separate functions, right? We've got the function for the route, and we've got the function in the database module, right? So we've got code in pet.js, which uses code in database.js. And so we have to just divvy it up and decide which module is responsible for that logic. What should this module do and what should that module do? And basically that whole decision comes down to something we call software engineering. Software engineering is this whole discipline of figuring out how to build good software and figuring out how do we architect things, what kind of design patterns do we follow, what kind of things should we be concerned about, and so that is a whole discipline in itself, just so we're clear. The part about what you put here and what you put here is a complete science. And there's not one right answer to it, long story short. There's not one right answer to it. I could put all of this code into the route and not have the database module at all. That's entirely possible. I could completely eliminate the database module and do it all in the route. I could also completely kind of scalp out everything in the route and do all of it in the database module, right? It's possible to do 100% here or 100% there. But the right answer is we want to do a little bit here and a little bit there, right? And so just the question is knowing what's what responsibility and what's the other responsibility. So we know for the database module, right, it has to be able to interact with the database. It definitely has to have the database connection, right? So things that have to do with the database connection should be here. If it has to do with the database connection, you want to put that code here. If it has to do with HTTP at all, it doesn't belong here. Anything referring to HTTP shouldn't be here because it doesn't know. It shouldn't know. So if you need to bring in an express, you're doing something wrong. If you need to bring in the request or the response, you're doing something wrong. Is that clear? The request and the response should never, ever, 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 ever appear in the database module. That's one hard and fast rule. If you pass the request or you pass the response into here, you are absolutely doing something wrong. And you shouldn't be doing it. Okay? So that's part of the constraint. We can give it data, but this has to not know where that data came from. Does that make sense? This can be fully in charge of figuring out how to update the database, but it can't know where did the inputs come from the user, right? How did the inputs get there? That's the job of the route. The route's job is to get the input from the user, validate it, make sure it's good, and then pass it on. And let our database module figure out how to actually modify the database. And any errors that occur, again, that's the route's job. Anything we need to send back to the user, that's again the route's job. Okay? Does that make sense? Okay. So that's where, this is doing, I can clearly say this is all database logic, right? There's nothing in regards to, I don't know how this function was called, I don't know how I got the data, I just know somehow I magically have the data. And that's part of, getting practice with this and knowing what to put there. Okay? Let's also look at the delete function. Delete function's pretty easy. You say, hey, I called it delete one pet. The only piece of information it needs to know is what pet to delete. So I pass in the ID. I say, let's go get the pets collection and delete one record from the pets collection. Okay. So in terms of modifying the database and getting back up to where we were yesterday, that's what I want you to bring in, is whether you have it or not or yet, go ahead and bring in these update one pet, delete one pet. If you got a different version there, please replace it with the code that I have here. If you wrote another version yesterday, please replace it with it.
Can you also show your pet data?
Yes, I will. Once everybody's got this code in, I'll show you what I've done in the route. Which, it turns out in my route actually got really, really simple. Because I'm doing it this way in this month, or maybe the other module. because notice the problem there, you're doing multiple updates to the database. You're making 4 trips to the database. So that's the other side of this, is you want to minimize how many trips you make to the database. Noting how many trips you're making, so I was kind of talking to Danny, noting the trips that you're making to the database is really important. You know, every time you say database do something, there's a network lag because you have to tell it to do it, has to do it, and then send the response back over the network. So you've got a forward and back trip over the network, and that can take some time. The fewer trips you can do it in, the faster it will be, and significantly faster. Plus avoiding some errors where maybe other things are happening at the same time. So I want to try and do things as few database operations as I can. Okay. I see a few people still typing. Does this all make sense now? What I'm doing with the update, with the ... kind of, sort of, maybe.
I have to get some practice. Or we're gonna look it up in the
Yeah.
documentation.
Yeah. So it's the Sprite Operator is what this is.
Never seen it.
Yeah. And remember, it's triple dot. If it's at the beginning, it's a spread. If it's at the end, it's the rest.
And that's what you showed us in the, I forget what you showed us in.
Oh, I flipped them.
Yeah.
I did flip them. You're right. I did it right down here. But yeah, no, this is I before is the spread and after is the rest.
You said
Sorry.
it out loud right all this time, but you said it consistently, but
I did it right here, and then I went and put it in my text in my I did it right on the whiteboard, and then I did it wrong here. So that just like the reason I point that out is that confused me for the longest time. It's like, well, how do you know that it's like, wait, there's 2 different operators that use the same symbol, but it means something different depending on where you use it?
plus.
Yeah. Except that plus plus is even closer than rest and spread. This is like, you can think of this as like times and divide.
Oh, I see.
It's inverted. It's the opposite operation. Okay, so now that we've got that in there, let's take a look at the route. Okay, so here, starting at line 69, going down to 85, you can see my update route. Okay, you might notice that there's a lot fewer if statements. Just kind of where I ended up and why I took that route of using the spread operator, because it ended up letting me do that. So what I did is I started out, I grabbed the pet ID, that's kind of the easy part. I just said request.params pet ID and convert it to an object ID, right? So say, hey, this is an object ID now, rather than a string. And then I said update. That's kind of the magic. update is just equal to request.body. And if it looks like that's easier than it should be, yeah, it took me a little bit of finagling with this the other day to kind of figure out what the easiest way to do it is, and that's where I ended up. But it took me a little bit to get there. So what I'm saying is take the entire request body and use that as the update document.
It will either contain something or no.
It won't. Yeah, exactly. So I'm already, in Postman, I can choose to send the species or not send the species. Or I can choose to send the name or not send the name. So I just do that. And if you're thinking of this in terms of a form, that means like if there's a name field, well, then the name is sent. If there's no name field, then the name isn't sent. So you can think of this as pulling off all of the form fields and saying, hey, we're going to update everything that's on the form. I might have to add a little bit more to that if I maybe had some additional fields in there that I wanted to do special things with. Then this would make this a little bit more complicated. But the good news is that's all I'm doing with this. I'm just saying, hey, take everything that you entered and we'll update that.
That's clever.
So that's how I got around not needing to check if things were undefined, because they're already undefined in that document. They're already not defined in there if they weren't set. Cool? Okay. So I take that. I'm doing a little bit of logging just so we can do some debugging and see what's going on. And this is kind of a good pattern to follow, is to make sure you're doing some debug to see if it works. I'm then going and saying, okay, let's find out if the pet is there, right? So if there, we've got the pet ID, let's see if there's a pet. Well, if there's no pet, we're going to just go ahead and say this is an error, say we couldn't find it. Yeah. So this is an extra kind of trick to the database, just to be clear. Doing this find. It is possible that I could eliminate that out because I can actually do the find and the update in one step. If I just look at kind of the return from the update, you can say, well, how many documents did it update? It should be a little bit more efficient, but this is a little bit easier to get started with and kind of understand without knowing too much about the nitty-gritty of how update just kind of works. So I just say, hey, let's go find it. All right, if it's not found, we're done. Otherwise, we're going to go down and follow this update one. So the only really error checking that's happening here is just to see if the pet exists. I'm not doing any error checking or any validation on the data that they sent in the body. Is everybody with me there? I'm not doing any validation on the data that came through as part of the body. That should raise some concerns. Okay, that should raise some concerns. So because I'm not doing any validation on that data, right, this is the simple version, there's a lot of things that I could do here that would result in problems in my database or security issues. Okay, so this is not where we're going to end. Okay, this is okay for where we are right now, because what I'm going to introduce on Monday next week is Joy, and I'm going to fix all of the issues that I've just introduced using Joy. Actually, I'm just going to use that to block all that misbehavior, just so we're good. Cool. And so these are not issues that I want you to fix right now because we're going to fix them with Joy. Is that clear? So I do want to, but we do want to look at what are those things that could go wrong, right? Okay, I'm going to pull up Postman, and I'm going to try and hit this service. So I'm going to open up a new terminal, and npm run start dev. get the server up and running. And yeah, so I'm going to go ahead and hit this with Postman. Server's gone. Going. Okay. So I'm going to do a get here, right? So first things first. Okay. So we can see that I'm getting the pet by ID, right? So I'm getting the pet by ID. That's one query that I've got here. And so I'm saying, okay, the species is cat, name is Fluffy, age is 10, gender is F, right? Okay. So let's go and try this update method. So if I leave it there, nothing checked, I don't send any data, okay? So it's going to come back and say the pet updated, right? And if I look at how the data updated, we can see that nothing changed except for the last updated field changed still, right? Despite the fact that I didn't change any fields, the last updated still changed. It's actually one of the reasons I have the last updated in there, because it makes it easier to see I did something. Cool? Okay. So we can see that points to today instead of yesterday. If I look at the logs here as well, because I went and logged what I got here on line 73, I logged, there's the ID, and you can see the object that it got was an empty object. So update was an empty object. Does that make sense? So let me go back to Postman. I'm going to check maybe age and gender. And I'm going to say that he is now 15 and M. So I'm going to change those two fields. I'm going to hit send. It's going to say it's updated. And if we look at the data now, you can see that those two fields have changed, right? So I can say, hey, I just want to update these two fields. It will update those two fields. And I can look at the way the data came through here. It's logging it as null prototype because there's no class there. But you can see it's got age 15 and gender M, but that's all that's in the data. Make sense? That's all that was an update, so those are the only two fields we updated. Everybody good with that? Now, can anybody spot the problem? Because there's a few different things that are maybe problematic here. Yeah.
It's like what's the body parameter you put in? If it's just an empty string, would it just keep it as an empty string?
That is a great question. That's one of the things to pay attention to. Okay, so let me set that as empty string. So gender blank, send. Yes, so it set it to empty string because I didn't validate the data that I received. Because I didn't validate the data, I'm basically allowing invalid data through, right? So I'm allowing the user to send blank. They could send anything else, and it would accept it and gladly go update the database. So it's not really protecting my database in any way, shape, or form. You know, I can leave it blank. I can enter something that's not a valid value. Or notice what happened with the age. It's also now being set to a string where previously it was an integer and should have been an integer, right? So I didn't do any validation around that to make sure that it came in as a number. Does that make sense? So I didn't check the data type. I didn't check that it was valid, etc., etc., etc. I didn't do any of those things. And we will need to add those, but I'm going to do that with Joy. Okay? Is that clear? So those are things that Joy can really help us with, is those parts. Another thing in here that's kind of nefarious is note that I can type in another value, maybe alive, true, hit send, and now it has an alive field. So I can send additional names and add additional properties to that object that didn't previously exist. Does that make sense? That's both a good thing and a bad thing. It's good because a lot of times we do want that functionality. A lot of times we do want that ability to set a field later that we didn't set initially. But I don't just want any user to be able to come in and add arbitrary columns to my data. Right? Does that make sense? I don't just want that to be wide open. In fact, if we look at where things stand, I think, let's see, did we check for that over here? Okay, so we did check for that when we inserted the data, but I didn't check for that when I updated the data. So the reason I'm not doing any of those checks over on this side is just because it's so much easier to do with Joy than to write the code out. That's all of that. Okay, so does that make sense? So those are the things to take note of as far as what's not working here, but these are not things that you need to fix in 4.1. We'll fix them in 4.2, if that makes sense as far as your lab is concerned. Cool. So there's some security vulnerabilities in there. That's okay, because I haven't really given you the tool yet that we're going to use to resolve those security issues. Good? Okay. Before we leave here, let's also look at delete. And delete should be pretty obvious. I get my ID, I log that we're deleting, I go call find pet by ID and check if it's there. If it's not there, then we go ahead and say the pet's not found. Otherwise, we go and delete it and send back the message that the pet was deleted. Easy peasy. Okay. Any questions on the delete method at all with that code? Does that all make sense? Okay. I am going to do one thing here. I'm going to go ahead and commit this code. And pull up GitHub. Okay. So linked in Discord is all of the code. If you want to go back and get all of my finished version of this, that way you can get all of the code. If you end up having missed something today or yesterday, then you can get all the code for this project. Cool. Now you can kind of see everything that I have over there. Cody, did you catch all that? I don't know if you're on voice or not. Cool. Okay, good. Okay. So that's kind of the last piece of the API, right? So we now have an API with all of those routes in place where you can get the list of all the pets, you can get an individual pet by its ID, you can add new pets, you can update pets, and you can delete pets. So we fit into that full CRUD sort of interface. Does that make sense? So we've got that. Now, one thing I want to kind of talk about real quick before you start on the lab is remember what I kind of said at the beginning of this. You want to usually use an Atlas cluster. I want you to use an Atlas cluster for your lab. But what we did here is we didn't use that Atlas cluster. So if we're looking at our configuration, remember that we've got a few config files here to work with. So like we've got default.json, right? And default.json is set to localhost, right? That's our default. It's actually a pretty good default. It's a pretty good default to assume that the server you're connecting to is on the same machine. And I actually wouldn't recommend changing that default. Okay? So one way you could go about this, if you wanted to connect to Atlas, you could just go and change default.json. And that would get you to connecting to Atlas. It actually would be that easy. So that's one way to solve it. The problem with that is, A, it makes it potentially harder maybe for somebody else to use it because, well, now it's defaulting to connecting to that database instead of, or your Atlas cluster into local, which might be a better starting point for somebody to not use your database. You're also uploading that to Git, right? And if you look at what's in your connection string, you might find you have some things that you don't necessarily want to expose, right? So let me just say here, if I were to look at, what my connection string is to like the mflix, right? So we've got that in that connection string, at least the one I got. This one is the one for the shell. Remember, okay, so we got the protocol to connect to it. That's okay. But I've got in here some information, right? Does any part of that look randomly generated? Any part of that domain name look random? Yeah. So when you spin up an Atlas cluster, that is a randomly generated string. Anything that's randomly generated, treat it like it's secret. Treat it like something you should guard and not let the outside world see. Okay? So that's a secret in and of itself. Those characters should be something that an attacker has to guess. Okay? I don't want just anybody to know that. And I may not want them to know even the database name, but this is the big thing here. Also remember, so basically the way that your connection string is going to look is going to look a little bit like this. It's kind of what you type into Compass. So in here, you also need to add the username and the password. Let me turn on view word wrap. So that's what the connection string is going to look like that you have. Make sense? So it's going to include not just this random sequence of characters, but it's also include your username and your password. And there's really no way around that. That has to be in your connection string. Okay? Or it has to be stored somewhere, right? Has to be stored somewhere so that you can connect to that database. Is everybody with me? So this is what we consider you know, passwords, usernames, server names, domain names. This thing as a whole is what we'd call a secret. Okay, secret is information that you need to keep private. Okay, how do we do that? Well, one of the ways we do that popularly is we use environment variables. Is we stick it in an environment variable, and that way it's kind of local to the machine where it's being held. And potentially the way you set up the environment variable, you can maybe scope it down to just that particular user account can see that environment variable. And not even all the users on the machine can see that environment variable. Cool? So that's how we're going to hide that environment variable. So you could set that in your operating system. And that's basically what we do when we go to deploy this to production. We basically set it in the operating system as an operating system level variable. Okay. Remember, the easy way to do this is an easy way to set an environment variable. That's part of why we pulled in .env. So actually, what we're going to do is I would go into my .env file, say db_url is equal to blah. And that's where I would put the fact that it's connecting to, that's where I would put this to know which database it's connecting to. That keeps it secret, doesn't expose it to the rest of the world. As long as you do one thing. Don't check in .env. Do not check in .env. If you check in .env, now your secret's in Git, and just pretend everything in Git is public knowledge. Because remember, Git keeps all of your code for eternity. It's basically in there. You can at any time go back and see a previous version of your code. And so even if I put it in there and take it out, I can still later go back and get that code, right? So if I check this file in, this .env file, I've got to pretend that password's been compromised. I've got to go change the password. Does that make sense? In fact, I've already shown you this password, so I'm going to have to go change that password. Right?
So how do we keep this secret?
You put it in here. As long as you put it in .env and don't check .env in, you're good.
Just don't check it, like just write Friday and it doesn't exist.
So remember what I said is I said don't check it in. Okay. So that's easy. Actually, the don't check it in is easy. Remember we added a Git Ignore at the beginning of this project? And I said the Git Ignore is absolutely vital. If we look through here, you will find that there's a line specifically calling out the .env file and saying don't check it in.
That's what we but you go up and check it in.
It's handled by the ignore file. So basically you don't really have to worry about that. As long as you're ignoring .env, that happens automatically. If I were to take this one line out, all of a sudden it's going to say, hey, there's this env file. Do you want to check it in? Let me actually show you that. So let's say I don't have this in my ignore file. Beep. Okay. You see how there's a little U there now? So U says that there's a brand new file that I could upload. And if I go look at the changes, hey, there's a brand new file and here's a modified file, right? So at this point it's saying, oh, you can commit that in because it's no longer ignored. Okay. And in fact, once you've checked something in, basically the ignore file doesn't matter. The ignore file only matters if you've never checked it in. Does that make sense? So if I didn't start with the .env, this file would have already been checked in version control. And so you would have to remove it, get it out of version control to get it back to being ignored. Does that make sense? there's another gotcha. Let me undo my change to the Git Ignore. So I'm going to do discard change here. So now that Git Ignore is back there, we're saying ignore.env. It is worth noting there are some cases where sometimes I overwrite the overwrite the rules with the Git Ignore. If I actually right-click here, where is it? Is it on this thing? Integrated terminal. Okay, so let's just say reveal in File Explorer because I'm not seeing it here. If I go to the file, remember I've got Tortoise Git installed here, so it's got some sort of icons on it. You'll notice that there's no icon on the .env file, right? These other ones have like a green check mark. That's because they've been checked in, but the .env doesn't have a mark because it's not been checked in. Okay. If I go to here and I say right-click Tortoise Git, you'll see that there's a little add button. Because technically you can, with Git, you can add files that are ignored. If you're not careful, you'll find yourself doing this. So if I right-click here and I say add, if I were to look at the commit screen, it would say that this is a change waiting to happen. Say, hey, do you want to commit env? Giving me the option. Because I told it I wanted it added. So you can queue up things to be added using that. Okay, you can stage, even though a file is ignored, just be forewarned that you can stage it. And that doesn't just appear here. If I go to VS Code, it'll actually show me the same thing in VS Code as it's been staged, but hasn't been committed yet. So I can unstage it pretty quickly here, just hitting the minus, and say I don't want to do that. So does that kind of make sense? So the Git Ignore's taking care of making sure that I don't accidentally do it, but there are still some ways that you can upload it if you needed to, or you could still accidentally upload it. So just kind of be careful with the tools. You know, as you see kind of in general, if I'm using the tools in VS Code to do the uploads, you're probably not going to do it accidentally. The one thing that would happen if I, for instance, had the wrong name here, notice it's just ignoring env or .env. So if I named env instead of .env, it is going to schedule it as something I check in. Does that make sense? It's only looking for that very specific name of .env. Okay. All right. Does that make sense? It's a secret. We want to protect it. We're going to put in an environment variable. And so that's one of the reasons that we ignore the .env file. That's one of the reasons we don't check it in. So because it's not checked in, if you go to another computer and try to run this, you would need to update this. You would need to add the DB URL again. One of the things that means is I need you to give me, in order to grade your stuff, I need your URLs. I do need all of you to send me your database URLs so that I can connect and test your projects. Cool? Because if we do it through the .env, I won't have that .env.
How would you suggest I set my environment up then? Should I just go home and set Windows environment variables so that I never upload an .env file?
You need to have a .env file. So you're just going to have the same .env file on this computer and your home computer.
All right, but it's not going to Git, so how do I get it across?
Send it to yourself any way you want to. Whether you email yourself, it's a common thing I do. I just email myself with files like that, or toss it in Discord and then pull it back out on the other side.
How do you want us to go, or how do you want us to go with our connection terms?
So one way you could do this, take that out a second. One way I can do this is if I were to go take this, and I'm going to do this real quick in the general chat, but you can actually, but you can do this on a one-on-one method. I should be able to just boop. So one way you can do that is just send the ENV over to me on Discord. That's fine. That would be sufficient. That's probably going to be the easiest way for me to get it if you just send it over to me on Discord. And that way, if you send it to me, well, then you can pull it down on your other computer. Does that answer that question, Evan? There's plenty of ways to do it. There's plenty of ways to get it from computer to computer. Any way that you can transfer files, you can transfer the file. Okay. So, we talked about how to get the connection string. Let's look at the lab that I want you working on for the rest of the week. So, if you look on inside Ranken, you'll see there's a lab 4.1. And I think I did share this kind of in working state yesterday. It wasn't quite done yet. So what this, 4.1 is your assignment for this week going through Friday. So if I remember right, the due date on this is on Friday. Some of you may get it done sooner. If you do, then start on 4.2. So this is going to pick up where your previous lab left off. So previously we started working on the issue tracker. In this, we're going to start migrating the data from using an array. We're storing in memory using an array for both the users and the bugs. And so I want you to migrate that to using a MongoDB database. This is kind of a combination of things that we've done before. So Lab 2.2, I had you design the database. Lab 3.2, we started the web application, the API. So you have some code for the API in place, and you have a database that you designed previously. So you want to use that design that you created in 2.2 and the data, as well as the design, the database, the Atlas cluster from 2.2, here together with the code you started in 3.2. Cool. So you've already created a GitHub repo. Don't create a new one. Just reuse the issue tracker repo that you have. There's some more dependencies that you'll need to install. There's some config files you'll need to remember to set those up. I've also called out here to say, hey, make sure that your .env file should look like this with the debug port, debug db URL, db name. So those settings you want to make sure are set. You can use a different port if you want. That's up to you. Just have a port setting in there. Also, there's some changes you'll need to make to the server.js, which we kind of walked through yesterday, namely pulling the port and the host name from there. I think I am missing. Oh, no, that's right. That's just those 2 lines of code. And then I'm giving you some starter code for the database module. So we kind of started and did this with pet adoption. Here's your kind of starting point with the connect and the ping and setting those things up. So you'll add in your own functions here in the middle and export those functions. So that's the stuff you still have to put in, is what are the functions that are specific to your application. Cool. This is a generic starting point. Honestly, you could probably use this database.js with any project, because all of this stuff as well, you're using Mongo, you need that as a starting point. So that's all very generic code. That's very boilerplate. There's a little bit, some updates to the best practices you'll notice. Just a reminder that you want to use 2 spaces for indentation, camel case for your naming, async await we kind of talked about, and so that's something that I want you to use for your asynchronous code, and try catch to handle the exception. So we've talked about some of that already, but there's some reminders there about that. So there's some instructions about how to update your user's API, and how to update your bugs API. Do read through all of it. There are a lot more things that have changed than you probably would assume. So I would really strongly recommend reading every single piece. There's a lot of little things that I had to tweak and update here and there. Okay? And part of that is how the error is sent back. I think I had some things incorrectly there and messages and such. So there's been a lot of updates in there in addition to just use a database. Okay? So that's it. Questions on the lab? Is that all kind of clear? Okay. Let you get to it. I will be here.